Alright, hello, welcome to a new video. Today we're in this problem called 226 invert binary tree. It is an easy code on LeetCode. So yeah, let's just get started with it. I had to search up the solution even though I already did it. I just want to make sure that I do understand it, and I think I do understand it, so I'll kind of showcase to you guys the problem solving process of it and how I go and think about it. Alright, so let's just, pretty simple problem, but let's just be consistent with our problem solving process. So given the root of a binary tree, invert the tree, return its root. Alright, so basically our input is just roots of bt, and then the output's supposed to be inverted input but inverted, right? So that makes sense. So for some notes, I don't really need notes, just invert it. But just again, basically, so invert, that means swap left and right. So yeah, and so for some questions, I don't think I have any questions other than like the size, just like the normal questions. So is the size, can our input have size of 0 nodes? If we can scroll down, and then it says that that's true, so I don't know, just to ask it, right? And then let's go through some examples to kind of showcase that we do understand the problem. I think it's best off if we just kind of solve it like this, or go through our examples like this. So if we have our input to be a tree of 1, 2, and 3, our end result that we want is basically we have the left and right swapped. So this is our left, this is right, and then we swap it, right? Kind of like that. So our end results right here. So we kind of want to do like that. But what if we have it, what if we have it in like this, right? So 1, 2, 3, then 4, and 5. Hold up, 4 and 5, and 6 and 7, right? How would that work? I'll just write it down here. We can have our operation to be like this. It's like 1, it's like 1, and then like 3, and then 2, and then they will carry on their like 4 and 5 and 6 and 7, and then from there it'll just be like 1, 3, 2, 7, 6, 5, 4, just something like that, right? So it's like 2 steps, I guess. Oops, looks weird. It's like 2 steps, I guess. So yeah, but I think if we go at it like this, if we start off small, right, it just makes sense, right? We start off 1, 2, and 3. We swap the left and right, so it'll be like this, 3 and 2. Pretty sloppy, but you get the idea, right? So we're just gonna follow this pattern. Yeah, so we went through some examples. We kind of asked some questions. We know what our input and output is, and took some notes of what invert actually means, because they don't really say it. It just says invert the tree. So yeah, it's pretty cool. So let's go ahead and code it up. In an actual interview, well, in some interviews that I've had, we kind of make our driver code. So let's make our driver code. Make a main function, run main, and then name, create a function to solve this problem. So I'm gonna name it invert tree. It's gonna take in our input, which is root, and then I'm gonna just go ahead. Usually they like give you like the tree node class, but I'm just gonna make it my own, just for practice, right? So val is equal to 0 by default, and then left is equal to none. Right equal to none by default, and then self that val is equal to the val, that left is equal to left, self that right is equal to right we're given. And then I'm going to create our driver code. I'm going to do this one, 1, 2, and 3. So say that test case, so test case 1 is equal to tree node, value 1, and then tc1.left is equal to tree node 2. And then tc1.right is equal to tree node 3. And then that's pretty much it. And then I'm gonna call invert tree with test case that we're given. And then we need a way to kind of like showcase how it works, or like showcase the output. So I'm just gonna make a in order. I'm gonna make an in order iteration or iterator function. So in order to take in a root or node, and then I'm going to say in order is basically like left, current, and then right. So let's say that in order go node.left, and then access the middle or the current. So then print out node.val, and then go to the right. So if this happens, so basically when we say before we invert it, I just want to call an order with node. And so, or with test case 1, I guess. And then this should print out, so 2, 1, 3, 1, 3. Right, so 2 left, current, and then right. And then after I swap it, we should have 3, 1, 2. 3, 1, 2. So we'll see. Alright, so now that we got that, let's go ahead and kind of plan what we want to do with our code. So basically, plan. I like to write my code in pseudocode. So first thing first, we're gonna deal with recursion. But when I do recursion, I like to have a separate function inside the function. So that first search could take in a node, I guess. Pass it for now, and then first off, we're gonna call that first search with the root we're given in this invert tree function, and then we're going to return the root. That's how I like to do it. So, and then now let's go ahead and actually code our that first search function to kind of iterate through. So first off, we start with the root, right? But by case, but by base case, I want to say that if we go to the bottom where our children have no other children, this is like a null node basically, or it's just null. So I'm gonna say, so if not node, then just return, just stop. But then if not, then what I really want to do is I kind of want to swap ready. So I guess I'm gonna say, I'm not even doing pseudocode actually. So I'm just gonna basically say swap left and right. So I can say that swap left and right, right? So first swap left and right, then and then go through left and right. Press left and right. So what I can do is I can say node.left and node.right. It's like a Python thing that we can do. But if you're in another language, you can do like temp, right? And then you kind of swap it like that. But in Python, we can swap it at the same time. So node.left is going to equal to node.right, and node.right is going to equal to node.left, which is cool. And then we have to kind of want to do the same thing on the left. So in this case, we swapped left and right, and now we want to swap these, right? So we want to call that first search on left, node.left, and that first search on node.right. And so once we do that, this operation will happen where this 3 will have its 7 and 6 swapped. This 6 and 7 swapped to 7 and 6, because we're doing it on the left and right, right? And then yeah, that's pretty much it. And so in this case, once we reached here, I guess, or even here, right? Once we reach here, where we already swapped it all the nodes, we're going to go through the children's left and right, and then it's going to satisfy the case where the node is null, and it's just going to stop the recursion here. So x x x x and then we're just going to get off, stop this function, and then we're going to return the root that we're originally given, which is this one. And yeah, that's pretty much it. So if this works, then we should see in the console that we're going to print out this first. Wait, hold up. I'm gonna print out this first. So, and then end line is equal to this space. And then let's print what's on the separate line. And so yeah, it should print out this first 213, left, current, right, and then once we run this function, it should have already swapped everything. So then it should run, it should return 312, 312. So let's see. Oh, did I do it wrong? Wait, did I actually do it wrong? If not, node. Turn root. It should be fine. Because if not node, then just return. None. Let's return. This shouldn't happen. So just right? It shouldn't happen. Yeah, anything wrong? Oops. Wait. Oops, this wasn't oopsie, that was my bad. So if not node, I didn't read the error. So if not node, then return return, I guess. So yeah. Let's run this. Okay, cool. So it does work. Yeah, this is exactly what we want to do. So yeah, yeah, that's a problem. To review its complexities, for space it's O of 1, because we're just using constant variables. We're not even using any extra, just using what we're given. So I don't know about that actually, but for time it's O of n, or it could be O of h, which is the height of the tree. I'm not sure. But it makes sense as O of n because for every node, right? We're just gonna swap it basically. So yeah,